It is legitimate. But we did get you on here for a reason, Bob, didn't we? Can you remember why?
Well,
I remember.
I heard it was something about ham radio and VHF and power.
There we go.
Or something.
I
That's
remember
right.
one of our pre-shows turned into, especially John Savage had a friend asking him about how a ham radio works on flat Earth, and him thinking that since my last name was Knodel, I might have some of the answers. And I was like, "You got the wrong Knodel." But the answers are easily at hand. And so, since we didn't have a show planned right now, and since I am in the making Mexican hamburgers, so it's hard to present.
Well,
We thought that we would have Bob come on and answer all of our questions about how does ham radio work on a flat Earth.
Oh,
Well,
you say our, you mean John's.
Well, thanks for that, Cami, because that's given me a little bit of impetus as to remembering what was going on. And what it was, I was watching a YouTube video called Introduction to Ham Radio.
Mm-hmm.
And halfway through it, he was saying, and this is going to really annoy the flat earthers out there, but VHF and the other one, UHF, are line of sight. And because we can't broadcast past a certain distance, this is point blank proof that it's going around the curve, that it's not, it can't go round the ball anymore. And I remember distinctly being emailed by from a US Air Force pilot quite a few years back. I won't say her name, but she was saying that someone was coming to her with exactly the same thing, and she came back with a fantastic screen grab, which I've lost, obviously. But it was saying it was basically the limiting factor was power. The power that you put into a VHF radio or a UHF radio is the limiting factor. So I'll pass it over to you, Bob, for any sort of clarification on that front.
Okay. Well, first of all, I will say that ham radio works a whole lot better on flat Earth than it would on a ball Earth. Okay. So
yes.
As far as line of sight, what they say about the line of sight, and this is going to come back to haunt them greatly when they say, "Oh, VHF and UHF only work on line of sight distances." Although that is true, the problem with that is that the line of sight distances that are not supposed to be line of sight, the VHF and UHF works beautifully on them, and of course the higher the frequency goes, VHF is typically around 150 megahertz. And for the ham specifically, it's between 144 and 148 megahertz. And then UHF is around the 450 megahertz band. So the higher in frequency you go, the more critical it actually becomes of having to be actual line of sight until you get, of course, to laser light. But as we all know, just like the laser light, we can see way too far. We can see hundreds of miles, and there are several instances of microwave and VHF and UHF transmissions going way, way, way hundreds, if not thousands of miles beyond the curve.
I have one for you right here, Bob. In fact, the day all this came up on the pre-show, a friend of mine was over. I've been knowing him for 40 years. We worked at a radio station here in South Louisiana together.
Mm-hmm.
And at night, we would boost our shows through our AM as well. And we got a letter from someone in Australia that heard our show from South Louisiana. So,
wow. And
where's
I've got
again?
an example of that as well. When I was in the IT business, we had a microwave link between London and Knutsford, and that was I think it was about 115 miles, but when it rained and things like that, it was a bit crap. But it was only a couple of years ago that I sort of started doing the maths on it. It was like, that just does not work. And I was told by my ham radio friend that it was repeaters. So again, it's something I can't prove either way, but please carry on, Bob.
Well, yeah, and repeaters are used extensively by the hams in both the 450, VHF and UHF bands. But for example, there was Cambium Networks that set a wireless broadband link record of 245 kilometers, which is what, something like 180 miles, something like
Yeah,
that.
right.
And that is way, way, way too far for the heights that they have at the antenna. And so essentially what it would have to be doing at that point, especially, they showed the topography, it would literally have to be curving around the earth. And of course, what do the ballers say? Oh, well, yeah,
Ducting.
it's ducting. It's ducting. Yeah. Now, microwave, I'm sorry, that you may be able to say that with the lower HF frequencies, but no, not with microwave frequencies. It requires an
Can you
absolute.
can you
But
stop and explain like the frequencies and how they look differently in the size of them, or is there any visualization you can give to that?
I can smell that burger from here. But
Oh,
carry
listen,
on.
you hear them?
Yeah, that's making me hungry.
yeah, sizzling.
They are sizzling.
But no, that's a good point. How do you? I mean, the microwave they punch through things, don't they? They don't bounce off things.
Well, the microwaves do have a tendency to bounce off of things. They will penetrate, um, but not, like I said, the higher the frequency, the less that becomes characteristic. Versus like AM radio, which is down, below 1 megahertz, and HF in general, will penetrate virtually anything, and VHF does too. VHF and UHF will actually penetrate structures. But like I said, when you start getting into microwave, that doesn't happen so much anymore.
That
Um,
makes a lot of sense because I mean, when the guy, the hoon up the street, comes around with his beatbox in the back of his car, that goes through walls, that goes through. I mean, you can't get away from it, but you can't hear the tweeter, the high
exactly,
pitch stuff. Okay.
exactly. That's a really good analog to compare it to. And as who is it? Ian Adams says so very correctly in the chat. He says the higher the aerial, the better. Well, why is that? Well, the reason is because when you get up into the higher frequencies, well, and this is true for low frequencies too, but especially in microwave, you have to uh, get past an area called the Fresnel zone, or the Fresnel zone, however you want to pronounce it. And basically, what the Fresnel zone is, and this is something that is related directly to the wavelength of the microwave itself. But essentially, there is a zone that is a vertical zone, if you will, that we're concerned about, that takes place from the transmission point, right? That it could potentially bounce off of things on the ground. And if you are not clear of obstruction in that Fresnel zone, you can get a condition called multipathing. And what multipathing is say you're transmitting from a specific point on the antenna and you have a straight line path, going from one antenna directly to the other.
Mm-hmm.
And there's also a path where if it's microwave or something, you can bounce off the ground and then bounce up to that other antenna. Well, unfortunately, when that happens, the two signals, the bounce signal and the direct signal, will come in at a little bit different times from each other. And therefore, they will come in at a little bit different phase from each other. And if this is a digital signal, what will happen is you'll start getting digital checksum errors, and they'll have to resend the packets over and over and over again. If it's analog, it just turns into a jumbled, echoey, weird, bizarre sounding mess, depending on how much time difference there is in between, the two signals arriving at that point, right?
Mm.
So that's the main thing that you've got to be considerate of. And of course, the higher the aerial, the better. But as far as what Cami was asking, when you're dealing with frequencies, the higher the frequencies, the shorter the wavelength becomes. Now, what does that mean? So essentially, if we assume, let's just say that all light and all radio waves travel at 186,282 miles per second. Okay, so if they are all at that fixed speed, and that's, we'll just assume that is true for sure. For this example anyway, if
Yeah,
you
we got you.
have, yeah, if you transmit a signal, the wavelength is essentially the first of all, the frequency is oscillating back and forth from positive to negative, back and forth and back and forth. And when we're talking about like microwave at 1 gigahertz, it's literally oscillating 1 billion times per second back and forth. Okay, so what the wavelength is in 1 second, um, the there will be one alternation of the wave, right? And the amount of physical space that is traversed by that radio wave is the wavelength. So when you have a higher frequency and it's oscillating faster, right? All things being the same as far as propagation speed, that means the wavelength is going to be shorter. Whereas if you have a lower frequency, it's oscillating at a much slower rate. That means the wavelength is going to be much, 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 much longer. Okay.
Yeah, that
So
makes sense. And that correlates with the, like the 10-meter band or the 20 and the 80 and that sort of thing. Is that right?
precisely. And that's exactly why they call it that, because the wavelength for a 10-meter band, which is about 28 megahertz, in free space will propagate about 35 feet, which is 10 meters.
Mm-hmm.
Right? And 2 meters at 146 megahertz, let's say, which is about 6.5, 7 feet. That's exactly how far that will propagate in free space.
And this is the reason why they call it millimeter wave, because the actual wave trough and peak are well, they're actually less than a millimeter. Is that right?
Yeah, exactly. And then you get nanometer, which of course is light, which is really, really, really small, because it's super duper high frequency. So, and that's a technical term that, super duper high frequency.
Super duper, yeah. Trademark, super duper. But
That's right.
I mean, I also heard this as part of the excuses that they were sort of saying, the higher up you go, the further the signal will go, and therefore that also proves we're somehow on a ball. But that works equally as well on a flat Earth, doesn't it? I mean,
Exactly.
elevation
If
just
not better.
is irrelevant, whether you're on a ball or a triangle or a flat plane. Elevation is irrelevant. But what about the power? What the pilot was saying about it being limited by power? Because I've got a friend who's an air traffic controller. And they say they can just boost the power and they can see 200, 300 miles. They can see airplanes landing in Manchester from London if they boost
Exactly.
the power far enough. So power is a key component, right?
It absolutely is. And they're talking about radar. And this is something, that's what I did in the Air Force was air traffic control radar, not as a controller, but as, the technician that went out and installed it, repaired it, et cetera. I also, after the Air Force worked in microwave. And yeah, if you turn up the power on radar, essentially what you're doing is you're putting out a much higher amplitude signal that when it finally gets to the target, right, it has a higher amplitude when it arrives at the target and then it bounces back to you. And it's just like anything else. If you have a really loud stereo and you turn up the volume, well, that wave of sound is going to propagate further and further and further. The exact same rules apply, and the same analogy would apply to radio frequencies, right? So yeah, turn up the power, and it works the same whether it's a ball or a flat plane. But unfortunately, the ball Earth, when you've got that geometric horizon that the ballers are now trying to deny, that would physically block microwave signals. And when I worked in microwaves, typically a typical microwave hop is anywhere between like 40 to 60 miles. And sometimes we would, bypass one, two, or three hops and get close to like 200 miles on some of these just for diagnostic purposes. And we would get solid signals coming back. Now, on a ball model, that would be absolutely impossible.
Possible, yeah.
Yeah, and what do the ballers say? Well, that's because it's ducting, and it's ducting through the ionosphere. And again, that doesn't happen so much with microwave. In fact, I doubt it happens at all, but I'm sure I would get a lot of feedback from people saying, oh, yes, it is true because it happens. No, the
So,
reason that happens is because it's flat. So,
yeah. I every time a friend of mine is ham radio, ex-army radio operator, sort of sends me stuff. I just can't. I- I'm. I can't think of any other reply other than Yeah, it's flat. That's why it's doing this. You don't have to make up all this other stuff and go through all the maths and the physics and everything about it. It's quite simply, it's
Yes.
because it's flat. But is there anything in ham radio that is a question mark? That is, I don't know. I don't understand why this does this, or is there anything in ham radio that you would consider like the best proof that the Earth is a ball? Because I can't see anything.
Oh, well, yeah, I can give you what the ham radio operators would say, and I would have thought the same thing too, until you start looking at other things. And what I will say about that is the ham radios will point towards a mode of operation that's called QRP. And essentially, all QRP means is very low power. Okay. So, what these hams will do is they will crank up a transmitter and they will put it down to about 1 watt, and they'll be able to work almost anywhere in the world. Now, this is when, and this is the HF band, and this is when the atmospheric ducting absolutely does take place. And that gets up into these ionized layers of the atmosphere, and it'll kind of trap it there, and it'll act like a waveguide. But here's something that's really interesting about this that a lot of people don't know, except for some of the very best QRP ham radio operators, and that is that you get the best QRP operations when you are on a major ley line, right? And this is crazy. There's a ley line called the 181 ley line, which happens to run right up the East Coast, and a lot of ham radio operators get some fabulous uh, low power conversations that go on from there. And so what's happening is these magnetic ley lines that we've all seen, you all heard about them. Of course, the mainstream denies that they're there because dowsing, people can actually pick them up via dowsing, et cetera, et cetera, et cetera. But there is something special about these ley lines, and what I think it is this all goes back to this magnetic grid, right? That's essentially what these ley lines are, is this magnetic grid, and they will act as sort of a waveguide in free space. And that's
Right.
why, and so that is, that's one thing that the ballers would point to, but none of them would ever, you'd say ley line and they'd go, yeah, right. Except, of course, for the very smart ones.
Well, interestingly enough, my amateur radio mate is his speciality is QRP.
Oh, there you go.
So I have now, mentally booked a time to drag him to Stonehenge and with his equipment, and let's see what we can do on that. Because, ley lines. I don't even think ley lines are denied by mainstream. They talk about them, they map them, they do everything else, but they don't. It's a sort of joke, but
right,
they're still there.
Ironically, while you were talking about it, I searched QRP radio, was kind of reviewing it, and then I just stuck in ley lines, and let me share my screen and show you what came up.
Okay, cool. Yeah, I've never researched it. I just knew about this from 40 years ago.
As soon as I typed in and added ley lines to QRP radio, anybody see anything interesting on the screen?
Oh, yeah. Bring it up.
There you go. And I had no knowledge of this.
I didn't either. This happened while you were talking about it. That is so awesome. That is awesome.
But also the ley line maps.
And then this grid over here. Yeah, that's pretty crazy.
I mean, they work so much better on the sort of standard flat Earth UN.
Yeah, I wish we could put that on the...
Well, bring that up. Ley lines on a flat Earth.
All right, hang on.
Yeah, my old Xanadude 60 logo used to have the ley lines overlaid on the flat Earth map.
Right, and that's
Thank you very much.
That's the image I'm thinking of.
Yep. Yes, Cammie did that. We did that.
She got it. She got it.
He was the one that did it. There it is.
Can you bring it up? Because I did a flower of life with Knodel points, because we are Knodels. So I don't know if you can, but it has all the Knodel points in there. I feel
if you have it, bring it up, Bob, because I just typed this in and got all kind of stuff.
I don't have it with me right in front of me. I think it's on my main machine, but
darn it.
And I'm on my laptop down in the living room.
Well, here's one that's on Pinterest. Oh, that's Ashley Webster, so that's pretty legit. Yeah. I know Ashley pretty well. we used to talk a lot on Twitter. It's been a while.
Now, the elite, believe it or not, are very, very interested in these ley lines, especially this 181 ley line, which goes through Teotihuacan, and it goes up across the eastern United States and then up across the eastern seaboard. And what's interesting about this is that 181 ley line crosses every single major quote unquote false flag event
Right.
as it goes up.
I saw that.
I mean, they know about it, and it's very, very significant to them. So, that's
Does
all
it
I'll say
go
about
anywhere? Does it go anywhere through England? Hopefully in Somerset Plains.
It might. I think it might have even gone through Stonehenge, but I'm not sure. I'd have to look it
I
up.
think
It's
so.
been a while since I looked at it. There's a guy on YouTube that specialized in researching just that ley line because
Yeah.
it's very significant.
I think me and Adam might have to pay a little visit to Stonehenge when he comes down.
That's one of the places I always wanted to visit. If I go to the UK, I wanted to visit Stonehenge, and also I want to see the crop circles.
Hey, sweetie,
Ditto.
what ley line is it that went between all of the churches on the line in England? Connected, all the chapels and
I don't remember.
The Rose Line.
the Rose line. Okay.
What number it was.
That's what it was, yeah.
Yep.
So to close up on the ham radio stuff, there's nothing that baffles you that says, this could be a globe. It's just...
Well, the one thing that I will say, and I have yet to see this, I have put out feelers, is of course, the entire EME moon bounce thing, right?
Yeah.
I hear about that constantly, and the research that I did on it, as a flat earther, it seems like for whatever reason, having a signal being processed and coming back to you through the internet is an integral part of this. Now, to me, that's really suspicious. But assuming that they were doing this long before the internet, okay, and I'll even say, okay, yeah, they were, or they thought they were, or whatever. We don't really know what the moon is, but it is clear, at least to me, that it has some sort of electromagnetic property to it, right? And it could very well be, reflecting a signal back, and it may even be such a weird property that it's reflecting it back at the proper time, right? So it's supposedly 250,000 miles away, and at 186,000 miles per second, you're talking about a second and a half there, second and a half back. There could be a 3-second delay, but it could be caused by any other property of this EM plasma mystery that we really don't know a lot about. So,
like a medium change.
Yeah, possibly like a refraction type of thing.
Who can really measure even a 3-second delay? I mean, is that possible? Or?
Oh, yeah, easily. We have instruments that are called TDRs, time domain reflectometers, that'll measure down in the nanoseconds as far as delays and stuff like that. So as far as the tech to be able to do it, yeah, it's there. And of course, if you apply that towards laser interferometry, and you guys have heard me talk about laser interferometry a lot, that's even more accurate, right? Because you're using literally phase differentials in light. Can
this be done off the sun as well as the moon?
Well, if you could send something to it, and supposedly they say they have, but again, because the sun is not, at least in my opinion, I don't believe that it is a physical terra firma thing.
Sure.
It's something else.
It does have magnetic properties, but it's also more of a disturbance than your lunar one. That I think you'd get more interference.
So do you think that means that there's more evidence that the moon is a physical terra firma thing, or could we just be bouncing off the dome?
I think it could be bouncing off the dome. In fact, I think that's one mode of propagation that they have talked about. There's a video out there that, the supposedly is a guy that was in the Defense Department. He's now on the run. And he was talking about, the elites found out about the dome a long time ago. And the reason that they were bombing, the upper atmosphere is they were trying to, fishbowl. And fishbowl is literally what they were supposedly trying to do was charge or ionize this dome. And what happens then is it gave it this very specific, strange property where it would bounce radio signals back at precisely the same angle that they came in at. In other words, it's not like a pool table, like when you hit a pool
like
ball.
A retro reflector.
Exactly, like a retro reflector, Precisely.
How
So
weird.
Wow, the gravity. Sorry, Bob. The Gravity Hill in Indiana. If you
Mhm.
look at that big purple circle and the big yellow circle, it's right where they cross.
Told you.
So, like I said, if you can bounce something off the alleged moon and get a 3-second signal back, then surely you should be able to bounce something off the alleged sun and get a 3-second signal back. But I would imagine no one knows anyone that has ever done this. Although it
no,
may be possible, it's not
I did
been
hear
done.
McToon, that MC Toon guy. I think when he was
Oh, God.
debating Adam, or maybe it was Adam or somebody else, he was saying, "Oh yeah, we know we put a radar signal off the sun, and whatever." But I doubt, at 93 million miles, it would have had a delay of 8.5 minutes, right? 8 1/3 minutes, or 16 minutes. Actually, you got to go there and back. So yeah, I doubt
I
it.
imagine it would be 3 seconds, if anything.
Yeah, and if it is, boy, that's pretty strong proof that the sun and the moon actually are at the same distance, whatever they are, right?
Yeah, wouldn't it be? Yeah, if you could actually, if you could, if we could do that, then yeah, wouldn't it be amazing if the reply signal came back at the same rate as the moon?
Mhm. And the person.
All I'd say on that, John, is tell me the medium between here and the moon, and then we can discuss the transmission rate between that medium, and then maybe we could discuss what the
there's
transmission
oxygen
rate
there, 'cause
meant in terms of distance.
it's within
Well,
Earth's atmosphere, so there has to be some oxygen. in it.
Absolutely. There you go. You see, you assume the medium between the Earth and the moon and the Earth and the sun is the same.
The person to ask about this, assuming, and that's assuming he wouldn't be breaking any of his security clearance oaths or whatever, would be Daytolan Media. But that guy works in DoD radar, for several contractors, Defense Department contractors, et cetera. And he, in FE Corps, he's made a few statements to some FE Corps members that frankly have blown my mind. and I really can't and shouldn't repeat them, but and I won't. But I mean,
Tease, man, right?
I can't. I mean, honestly, I don't want to get the guy in trouble.
No, I understand.
But
He's a special kind of guy, though.
Certainly extend an invitation for us if he would like to come on and talk about any of it. He is welcome anytime.
Yeah,
I was just watching his Florida video, and it's just unbelievable. To me, it's just so bloody obvious. But I'm not wrong in thinking that Mr. Tolan may think the Earth is moving.
he has made a statement that it could be interpreted that way, but I've yet to pin him down on it. And again, this goes to something, and I think honestly, where that comes from, John, is the same thing that we have discovered with the ether. This rotational property of the ether, and really, it's not top secret or anything. It's something that was known going all the way back to Michelson Gale, right?
No, you're right. But it is a sort of a knife edge. You either go this way or that way. It seems anyway. I mean, I'm
Right.
still sitting back, although I'm absolutely more on the side of we're detecting movement in the heavens above us.
Mm-hmm.
But other people, I don't know. It's I don't know.
Yeah, he is in a very unique position, let's put it that way. But there are some things that he may be required to say publicly, as far as this type of thing. In other words, he
Gotcha.
can't really say, and that would be expected, right? Because he would have to protect himself and anything like that. And that I understand. But
I mean, if I only had the fog results to go on, and that was it, then there would be doubt in my mind. But the truth is that it's what you say. It's the preponderance of evidence. It's the fog. It's Aries. It's Michelson-Morley, Michelson-Gale, Sagnac, gyroscopes. You name it. that
Mhm.
it's just, to highlight one issue and then go, okay, well, that just means we're on a spinning ball or whatever, just seems irrational to me.
Yeah, I agree. I agree. There's enough evidence out there, and this is something I've always believed that, no matter what truth you are seeking, it seems to be a rule, a universal type of rule, that for those who are seeking specific truths and answers, they must be provided somewhere. Now, the way that they're provided, it could be put out there in jest and ridicule, or directly in your face, whatever. Um, I believe that that's kind of a rule that has to be adhered to, no matter how much deception. And the elites seem to play by that rule. And some people may see it that way, others may not. But I personally believe that that is the case. And I think that all the information that we really would be seeking, if we are earnest in our seeking of it, those answers will be provided. They will be forthcoming in some way or another.
Yeah, I think whatever you believe, there is a place for you on the internet somewhere.
Well, there's that too. Yeah.
Oh, I like that.